Cool. All right. Well, let's go ahead and get this thing rolling. So, welcome everybody to today's HumanSignal webinar. Pretty excited to have you join us, and we're really excited about today's topic. Just a couple of announcements before we kick into the presentation. First is we will be recording this webinar, and we will share the recording with you afterwards. So, you'll be able to go back, rewatch it, maybe pick up some of the stuff that you missed as you go through the process, because this is definitely going to be hands-on with code examples, etc. The other thing is that we will have some time for some Q&A after the presentation. So like after the tutorial, Micaela will have, depending on how long the presentation takes, between 15 and 20 minutes to answer questions. So if you have questions that you would like to have Micaela answer, if you look at the bottom of your Zoom toolbar, there's a Q&A widget. You can click that, it'll pull up a box, just put your question in there, and then Micaela will answer as many as she has time for. So go ahead and drop those in there. But with that, that's pretty much it for announcements. So I'm just gonna go ahead and introduce our speaker and our topic. So today's webinar is fine-tuning Llama 3, adapting LLMs for specialized domains, which I think is a pretty cool topic and definitely so hot right now. And to tell you a little bit about Micaela, she's our machine learning evangelist here at HumanSignal. But previous to her working here at HumanSignal, she actually worked at SiriusXM as a data scientist. So she really understands this stuff on a deep level. And we're really lucky to have her and excited to have her share her experience with us. So with all of that, I'm going to go ahead and turn it over to Micaela. And thanks again, everybody, for joining.
Thanks, Nate. And just to answer a quick question that we've already seen, yes, this will be recorded. So welcome to the webinar. I'm excited to talk to you today about fine-tuning Llama 3. So we'll get started with just a couple of slides. So the first question I want to answer is what is fine-tuning and why would you even bother fine-tuning a model? So fine-tuning is the process of adapting a pre-trained model for a specific task or use case. And it often sort of comes in at the end of a process. So usually you'll start with an off-the-shelf LLM, maybe Llama 3, maybe GPT-4, whatever you got. You'll see how it performs in your data. Then maybe you'll try some RAG or some other ways of injecting your own knowledge into your model. And when all else fails, or when you're ready to sort of make your own custom model, you'll dive into fine-tuning. And there's a few reasons that you might want to fine-tune a model. The first is to prevent hallucinations. We know that models sometimes make things up. And along the same lines, we want to ensure factual correctness of our models. And finally, another reason to fine-tune is that it helps provide details in niche areas that can help you leverage unpublished information. So maybe you have custom information about your company, maybe you're working with PHI data or healthcare data, maybe with financial records, things like that, where you want your model to understand and know information about these things without making it public to the world, or if it's not public on the internet. Fine-tuning is a really great option for you. And the fine-tuning process is cyclical. So we're going to go ahead and walk through an example today on medical Q&A, because as we mentioned earlier, medicine is a really great example of a place where you might have a little bit more niche information than is available on the wider internet. So we'll start with an initial tuning or initial observation of how Llama 3, the 8 billion parameter version, works. We'll then use the MedChat dataset to sort of help us evaluate that model and do some fine-tuning of Llama 3 on the MedChat dataset. From there, we'll see that our model needs a little bit more fine-tuning. So we'll use this fine-tuned model to help us generate some questions and generate some answers to those questions on another data set called MedDal. And then we'll go ahead and fine-tune our model on these generated answers and questions. As always, we recommend keeping a human in the loop for all steps of the process, because with all machine learning practices, garbage in is garbage out. And keeping a human in the loop really allows you to understand those practices and what's happening in your model. So without further ado, we will dive right into the example here. First, I have Label Studio running on my local machine. This is the open source version of the product. As you can see, I have no projects here for this tutorial. So this is going to be a fully live demo. Hopefully that works in my favor. We're also going to be leveraging this medical Q&A example Jupyter Notebook that you can go ahead and run as well. We'll send it to you as part of the blog post that comes out after this webinar. There are a few different cells that are above this that I'm not going to show you that I have already run. These are the ones that set up your Label Studio API interface, but they include a secret API key, which is why I can't show it to you. So the first thing that we'll go ahead and do is we'll import the MedChat Q&A dataset into our Jupyter notebook here. And we can see that the first question answer pair we just printed on the screen so we can get a sense of what this data looks like. So what is one of the methods of administering this drug for intravenous infusion in a peripheral or central vein? Cool. We're looking at medical Q&A. The next thing we're going to do is create a Label Studio project using the Label Studio SDK. So we have that set up for you here. This is the labeling config that we're going to be using here. As you can see, there's a bunch of formatting things that happen, and then we get into the sort of pseudo HTML coding that sets up our interface. So we'll go ahead and run that. We're also going to set up our ML backend for this model. So we're using an example notebook here called, not that one, LLM Interactive. And if you open up the Docker Compose, you'll see that there are a few things that we need to fill in here. For our OpenAI provider, we're going to use Llama for this demo, but you could also use Azure or OpenAI here. Because we're using Llama, we're going to use Llama 3 as our model here, and we'll skip the OpenAI API key. We're going to use we're not going to use an internal prompt template here. We're going to go ahead and use our own template here. We're going to fill it in for every question as we go. And then for our Llama endpoint, we're going to use host docker internal :11434/v1. The reason we have to call it host.docker internal is because these are both hosted in our local host. And when you have one Docker container referencing another Docker container, the whole local host thing gets a little messy. But with that running, with that all set up, rather, we can go ahead and open our terminal window. As you can see, I've already run Llama run Llama 3. So our Llama 3 model is up and running. I've also already gone ahead and started running our Docker Compose. I run Docker Compose up for our Docker container that will run our ML backend. So that is all up and running and good to go. And finally, we're going to use ngrok here just to help us connect to our Docker container. Again, for localhost reasons, it's just easier this way. So I'm going to go ahead and copy this forwarding address. And now if I go back to Label Studio and I refresh this page, we should see that our Project 1 MedChat has been up and running. So I'm going to go ahead and go into settings, go to model, and we're going to connect that model that we just connected. So we'll call it Llama 3. We'll give it this backend URL. We'll turn on interactive predictions. We'll validate and save. While that's working, we're going to go ahead and add some tasks into our project. So here we're just going to add all of the tasks that are in the training data set from MedChat. So we'll go ahead and run that. Give that a second to process. And then if we go back to our project, you should see that it's now populated with all of these questions and answers. So cool. So the first thing we need to do in our fine-tuning process is sort of evaluate how well this off-the-shelf model works in the first place. So we'll go ahead and we'll click into our example. You can see the auto annotation is turned on, and we're going to give it a prompt. We're going to say, answer the question, and we're going to provide these curly brackets text thing. This is how we tell the model in the prompt to use a section from our metadata. This is the text field up here. We'll go ahead and click add, and you can see now that the model is thinking on the back end with this little yellow circle. It's connecting to Llama. It's going to predict on our data. It's going to generate an answer. It's going to put that answer into Label Studio format and put it all back into Label Studio for us. Here it goes. And now we can see that we have an answer to the question, what medical conditions are contradicted with the use of, I'm not even going to try to pronounce that. I don't do medicine. And I don't want to butcher it, but you can see here that we have a whole answer. This is the part where you'd want a subject matter expert or an SME to come through and really evaluate, does this answer adhere to what we're looking for, yes or no? We'll go ahead and submit that as if it's correct. I also want to highlight here that if we go back to our project, we can have multiple predictions happening at a time. So we'll go ahead and select 3 tasks for now, but you could select as many as you want. And we're going to hit retrieve predictions, which is going to go ahead and call the ML backend on all of these tasks all at once. It'll take a minute to think, but then it should populate for us the answers to these questions. So we'll give that just 1 second. Perfect. You can see now that the answers have been populated. This column keeps track of how many predictions there are. And if we click in, you can see this one, it didn't answer the text correctly. But you see in this one, it did, in fact, answer the question the right way. This is a really great example of the model not having enough information to answer the question that's provided. This is why you really want to keep a human in the loop. You don't necessarily want to trust the model right off the bat. It didn't know the answer. It doesn't always know the answer. But we'll go ahead and submit some of these just to sort of show that process. I think we annotated the third as well. So we know here that the answer is initiate with 10 milligrams once daily. The pediatric rate here is not exactly the same answer. And I don't know enough about medicine to know if that is the correct answer or not. And again, this is why you'd want to keep a human in the loop. So now we've seen that this off-the-shelf model works sometimes, doesn't necessarily work all the time. I think we're ready to fine tune. So we're going to go ahead now and we're going to use the MedChat dataset off the shelf as it exists for fine tuning, but know that you could always take the data that you've collected in this Q&A project that we were just in, upload or download it to your system and use that for fine tuning instead. This notebook will also be available in the blog post that we send you after the webinar, so no need to worry about getting all of it done right now. I've already gone ahead and run this notebook because fine tuning does take a little bit of time. And pull a little bit of a Martha Stewart. I'll show you how it works. Then I'll have a pre-finished version ready out of the oven for you. So we're going to install some things. Then we'll set up a fast language model from Unslav. We'll then go ahead and add some LoRa adapters, which make it so that we only need to update 1 to 10% of all of our parameters instead of all of them, which makes fine tuning much faster. We'll then go ahead and prepare our data. So we'll put it into the chat prompt format that the model is expecting. We give it this format, and then we can go ahead and format all of our functions, all of our prompts that way. We'll load in the data set. We'll do some tokenization. We'll create a nice, pretty formatted data set for us to use. And then we'll go ahead and train the model. Training the model with the way we have it set up took about an hour. You can always go ahead and change some of these parameters. For a full run or for a partial run, or play with it for however you might need. We give some instructions for that here at the top. After training, we can run inference on our new model just to make sure that it works. And then you're going to want to save that model. We're going to save the GGUF part of the model. And then we can create this tuned Llama 3.8b file. It doesn't matter where you put it as long as you point to it when you go into Llama. This model file is going to help us run it with Llama. So you can go ahead and just copy all of this and paste it directly into that file, save that file wherever you'd like. And then when you run these commands down here, Llama create, you'll just make sure you pass it instead of /tuned llama 3.8b, you'll make sure you pass it whatever path you've just given it. So we can go ahead now, go back to my Llama. We're going to quit out of Llama 3. We can go ahead and run Llama list. I've already created this tuned Llama 3.8b, as you can see up here. And then we can run that model. It's thinking. While it thinks, we're going to go ahead and copy the name of this model. And we're going to edit our Docker Compose that we were using before to use this model. So instead of Llama 3, we're going to use tuned Llama 3.8b. All good. Everything else can stay the same. When I'll go back to our Docker Compose, we're going to rerun this Docker Compose command so that it uses the new Docker Compose file that we just updated. That is getting ready to go. And then we can use the same forwarding link as before. So we'll go back to our Jupyter notebook here. Actually, I'll hop back to the slides just for 1 second. So we've completed this initial fine tuning. We're now going to expand our data set. The MedChat data set is not that big. And as you'll see, doesn't do a great job fine tuning the model because it doesn't have quite enough data to do so. So we're going to go ahead and create our own question answer data set based on the MedDel data set itself. So we're going to create 2 projects here. We're going to create a question generation project and an answer generation project. And we're going to use one to inform the other. And the reason we're going to do it this way is because we want to make sure that we get good inputs that have been human checked so that we don't have a garbage in, garbage out problem in our models. So the first thing we're going to go ahead and do here is we're going to create this new MedDel questions project the same way we did before using the API. We're going to go ahead and load in our med-del dataset. And we're going to go ahead and import some tasks into that project. So if we go back to Label Studio, we go back to projects, we now see that we have this second med-del dataset. We're going to go ahead and connect our ML backend the same way we did before. We'll call it tuned Llama 3. We'll give it the same backend URL. We'll turn on interactive pre-annotations. Beautiful. So let's take a quick look at what this data looks like. We can see that we have some text here around some medical stuff. I actually don't even know what it is. Again, I don't practice medicine. I'm not a doctor. And then we have a place for a question prompt and for proposed questions. Something I want to highlight here is that for question generation, it's really important to have a really strong prompt. And when we're not going to focus on prompt fine-tuning in this webinar per se, we did do some prompt tuning on this prompt already, and we're going to go ahead and copy that prompt that we've already done. If people have questions about prompt fine-tuning, I'm happy to answer them towards the end of this webinar. If we have time, you can go ahead and drop them in the Q&A section below. But we're going to go ahead and copy this prompt, and we'll go ahead and paste this question prompt in here, and we'll submit that. And as you can see, again, the model is thinking. And what it's doing here is we're asking it to generate some questions. We give it some examples about how it should generate these questions. Using the example of the template, tailoring questions to different parts of the text to maximize datasets utility and accuracy. And you can see here that even though we didn't particularly ask it to, it has also generated answers. And it's given us a couple of these questions. So we're going to go ahead and submit this example. And then just like before, we're going to go ahead and do some batch prediction just to speed up our time to be able to get the rest of the information in this webinar. So we're going to go ahead and retrieve predictions on these. We'll give that a minute to talk, or to think rather. Models can't talk. Models can't really think either. Models are models. It's all math. It's important not to anthropomorphize your models. But while that's working, we will hang tight for just a second. These are a little bit heftier. These do take a little bit more time. Great. So we can go ahead and in here, we can look at these lists of proposed questions. This time it only asked one question, but we'll go ahead and submit that. And then we have another couple of answers and questions, which we can submit here as well. And we'll do the third one. Again, question and answer. Great. So now that these have been saved successfully, we can go ahead and do some answer generation. So now that we have a list of proposed questions, we're going to go ahead and create a new project for answer generation. And the first thing we're going to do here down in this cell with the 23 is we're going to download all of the questions that we just submitted from our questions task. We have 4 submitted questions. And then we're going to take a look at what those look like. So if you take a look here, you can see that we get this whole JSON structure that gives us a lot of information about what our annotation looks like. For more about the Label Studio JSON structure, you can hop into our documentation. Then we're going to format this as a Hugging Face dataset just for ease of use. And then we're going to insert that into our new project. So if we go ahead here and we go back to our projects tab, you can see now that we have a new question, or a new project rather, for answer generation. Once again, we will go ahead and connect our model. We'll call it tuned Llama 3 again. I need to go grab that URL. There we go. And we'll turn on interactive pre-annotations. While that works, once again, we have gone ahead and tuned a prompt on this already. So we're going to go ahead and copy this prompt. And if we go back to our data set and click in, you can see there's a little bit of misparsing in this first question. That's because of the way that the model didn't properly generate our answers the way that we expected it to. We asked for a list of questions. It gave us question, answer, question, answer. And so we've now uploaded all of these as sort of their own thing. This is a really good case of not being able to necessarily trust a model, although OpenAI did recently release a thing on structured outputs, which would have been really helpful here. And it's maybe something we can leverage in the future. So I'm going to jump down to this one that has a question. Which section of this medical article provides information on the potential benefits? We're going to go ahead and ask it to create an answer. I don't think this is going to work that well because this question is that good. But we'll go ahead and see how it does. It's thinking. And it just says, yes, there is a thing. And that's not that helpful. So let's go on to another question. This one looks like it might be a little bit better. What are the specific mechanisms through which SVAP is thought to prevent cardiac fibrosis? Okay, that seems like a pretty good question to me. Although again, you would want a subject matter expert to go ahead and use this. So we'll give it a second to answer. Here it provides us an answer as well as the source text, which is helpful. Yes, I can slow down. Sorry for speaking too fast. There's just a lot of material to get through. So once we've gone ahead and sort of generated a few questions and answers, we will go back to our data set or our Jupyter notebook here, and we will curate our data set. So the first thing we're going to do is go ahead. I need to submit these tests. Let me just submit that really quick while it thinks. What we're going to want to do now is go ahead and we're going to download the answers that we got from our Label Studio tasks. I only submitted one, so we only have one. We're going to go ahead and extract the answer data. From there, we can now see what that looks like. And then we would want to push it to, in this case, to the hub, which is Hugging Face's hub. You can provide your Hugging Face username. I'm not going to do that here. I don't have that set up. And then you could use the same structure as we used before to go ahead and fine tune your model on this Q&A dataset that we just generated. So that is I know I threw a lot at you in a very short amount of time, but that is a great introduction to sort of what fine tuning is and how you would do it with Label Studio. And with that, I will hand it back over to Nate.
Awesome. Thank you so much, Micaela. So yeah, now that we've gone through that part, we have come to the Q&A section of our program. So it looks like we've got a few questions that have been submitted. While we go, you can continue to submit questions. We'll get to as many as we can as we go through. And yeah, let me just jump into the list really quickly. Okay, so first question is, what should I do if the prediction is wrong?
That's a really great question, and I'm really glad that was called out. So it's not the way this project is set up, but in many Label Studio projects, you can go ahead and click into this proposed answer box and edit it directly. And you can go ahead and make whatever changes you need to make. You can go ahead and make whatever corrections need to be made. And then when you update or submit that annotation, it'll be marked with your changes. And that change gets marked as an event in Label Studio. So you can see exactly what changes were made by humans and how those were made. You want to be really careful to make sure that you only keep good answers or good questions that are generated. And if the model predicts wrong, it's a really great metric to have. You might want to have your own other metrics here. This is a pretty simple project that we've created, but you can always have a checkbox that maybe says right or wrong, good or bad. That way you can filter on the back end if you export all of your datasets there. But definitely you want to make sure that you're keeping a human in the loop, making sure that you're checking your model answers and seeing how those are performing.
Perfect. All right. Here's another question. Somebody just asking what hardware you're using. Looks like it's Apple Silicon, but how much RAM and
Sure.
CPU?
Yeah, I don't exactly know the specs of my computer. I am on Apple Silicon, but that is what Llama really comes into play here for. So we're using Llama, which allows you to host large language models on your local machine without really having to worry about CPU and RAM and all of that jazz. I can certainly send a link to Llama after the webinar. I think it's linked in the blog as well. And if it's not, you could just Google Llama. And that's a great question.
So there's another question that I think this flows really nicely into, but somebody asked, can the backend be configured to call custom provider like OpenAI compatible servers, et cetera? So does it have to be Llama?
Absolutely. So the way this particular example is set up, LLM Interactive, we can easily integrate with OpenAI or Azure or Llama. That said, you can always write your own ML backend. It's completely configurable to any model that you might want to host, LLM or otherwise. We have a lot of really great documentation for that on our website. There's also a video that I put out a few weeks ago that's a deep dive into how the ML backend is configured. And you can certainly reach out to me or anyone else, and we can happily give you the link to how that works.
Right, perfect. We have another question here. It says, are there good pointers on how we should think about evaluating the quality of questions and answers, like what attributes we should track or we might track, et cetera?
Yeah, that's a great question. As far as the quality of question and answers is concerned, I'm sure there are some standardized metrics. I'm not super familiar with question and answer, so I'd have to Google what they are. But you want to make sure that your answer questions really do come from the text and that the answers really are there. So a really good way to do that is by asking your model to give its reason why or cite its sources. Which can be a really great way of sort of ensuring that your answer is factually correct as given the response that you have. But again, this is why you want to keep a human in the loop, why you want to make sure that you're um, keeping a close eye on what's happening in your data and all that jazz.
All right, perfect. All right, let's
There's a
see
question
here.
about data
Going through.
security that I would love to get to.
Oh, yeah,
A couple of questions about data security, actually.
yeah. So,
Um,
yeah, this one here, I'll let you go ahead and let you jump into those ones.
Sure. So this question asks, how do we ensure that the model doesn't leak private data outside my company's infrastructure, doesn't disclose PII or other sensitive information, does not use SQL injections or other methods to break in data they're not authorized to view or edit? Um, and additionally, there was one here somewhere else that I can't seem to find right now. But essentially, the question is, how do we make sure that our models stay secure? Um, this is part of where fine-tuning a model really does help because it only has access to your data. And if you don't publish that model anywhere, it can't be used by anybody else but you. Similarly, if you don't sort of give your model access to other types of information, it won't use that kind of information. And Label Studio itself does not ever really touch your data. Like it's viewable in our system, it's editable in our system, but we as Label Studio are not saving it anywhere. So it really does stay secure. As far as not disclosing PII or other insensitive information to other users, that's a known problem about LLMs right now. And it's a really great reason to not necessarily trust them off the bat. And that's a problem that's still being worked on by researchers today. And so it's not something that I can give an easy answer to. But I think it is a good question. Someone else really quickly just asked, what is the app for the Llama desktop icon on your desktop? It's this little llama. I don't know if you can see it on my screen in the toolbar. I don't know if that's visible to all of you. But it's like a little white square with a little llama drawing in it. Um, let's see what other questions there are. Nate, any that are sending out to you?
Yeah, I've got a couple here that I think might be interesting. So somebody asked what some good practices for quality control might be.
Sure. There's a number of ways to go about this. The first is, of course, to have a human keep an eye on your model output. That's the best way to do it is to really keep an eye on your humans. Um, Label Studio offers a number of ways to do this. We offer straight annotation. In our enterprise version, we offer even reviewer workflows where you can have a second layer of person review on top of your annotators to sort of confirm that their answers are correct. There's also a number of ways that you can sort of use machine learning or sort of more data-centric tools to check how your model is doing. There's lots of like embedding features that you might be able to use to see if a question and answer match up semantically. You can always do like a straight token match to see how well those are answering and pairing up. There's also a question here that I see, is there a way aside from human in the loop to assess quality like multi-consensus layers? We often work with what we call LLM as a jury, which is sort of like LLM as a judge, except that it uses more than one model, where essentially you would ask your model, you'd ask one LLM, hey, I need to generate a bunch of questions from this text, or generate question and answers. And then you can ask a second model, hey, given this question, does this answer the question? And sort of reformulate your questions that way. So there's a number of techniques you can use to go ahead and do that.
Awesome. There's another question here I think is interesting, just kind of dealing with the process of what you were going through, but the difference between auto annotations and interactive.
Sure. That is a great question. It's something I only learned the answer to relatively recently. Essentially, let's go back to our model settings here. I believe what you're asking about is in your model configuration, this interactive pre-annotations button that we've toggled on. Interactive pre-annotations enables us to add inputs into our UI that are then sent to the ML backend. Without this turned on, you can still do pre-annotations, but nothing that you add in the front end will be sent to your backend model. So in this case, we need to make sure it's turned on because we're going ahead and providing the prompt on the fly to our model. But if we had a prompt that we set that we wanted to use for all of our models or all of our texts rather, we could turn off interactive pre-annotations and it would still work fine. I hope that answers the question.
Perfect. Okay, so there's another question here. Interested in your thoughts on this, but what is the overall good size of a data set to fine tune on, like for this first phase? And when do you know like when to stop? Just
That's a
in
great
general
question.
terms.
Um, it's hard to give a general answer because it is so specific to your data. Different models will have different sort of baseline understandings of different fields. So if you're, let's say, working on fine-tuning a model on medicine, as we saw in this demonstration, the model has some understanding about medical text to begin with. But let's say you are, I don't know, fine-tuning on financial data that the model might not have access to because it's not public. You might need to do a lot more fine-tuning to sort of give the model that information. In general, it also depends on the technique that you're using, but I would suggest probably a few hundred to start and then maybe iterate from there. Again, fine-tuning, much like all of machine learning, is an extremely iterative process, and you're going to need to keep going to see how well your model performs. I would also recommend that you use a tool like Llama Studio or something else to go ahead and create a test data set that has the correct answer to a series of questions or a series of correct predictions on a series of tasks that you can use to then compare how your different models are performing. So let's say you have a baseline model that you can run on this data set that has the correct answers. You can calculate your accuracy or your F1 or your precision or your recall or whatever, get an understanding of how that model is doing from a data specific standpoint, fine tune it, run it on the same set, make sure you don't use that test set in your training. It'll screw up your model. And then you can have a standard place to compare it back to see how your model is performing. At some point, you might start to overfit, which is when the model learns the answer to the questions you're asking it by memory and not by actual learning. So you're going to want to be careful of that. But otherwise, that's how I would go about doing this.
Awesome. Okay, cool. I guess there's actually a follow-up question to that, and that is, would it be meaningful to have an additional unsupervised fine-tuning stage on unstructured raw relevant data corpus before the supervised stage?
It definitely could. It depends again on your use case and what you're doing. But definitely, if you're trying to just inject knowledge into your model, that could be a really good way to do it.
Perfect. All right. Let's see here. Somebody here, this is a little bit more of like a theoretical question, I guess. But what's the time horizon for fine tuning via RLHF? And do you envision a world where synthetic data one day is better than humans? And if so, when would that be?
Sure. As far as the time horizon for fine-tuning via RLHF, I don't know. I'm not going to try to speculate on time horizons here. That feels like something I don't have enough information to answer. But as far as trusting synthetic data is concerned, I think it's a really helpful tool. I think it's a really great way to expand your data sets. But I don't think it will surpass humans anytime soon. And I also think that we shouldn't be blindly trusting the output of a model. We know that these models often hallucinate. We know that these models are only as good as the data that they're trained on. And so that's why we have to keep updating these models. That's why GPT continuously updates itself. There's ones with different dates because we know that the model is only as good as the data it has. And I think that keeping a human in the loop is really, really important to make sure that you know exactly what's happening in your model and what your model is doing. And I think that there's also sort of responsible AI focused reasons for doing this so that you can know really what's in your data, what biases might be presented unintentionally, where your model is performing well, where it might need more fine tuning. And I think being in touch with your data is a really important part of the machine learning process.
Perfect. Thank you. Okay, we've got one other here. Somebody was asking if you had any recommendations for using Llama for image recognition tasks. So like if you wanted to train a model and query images using language, how would you
Sure.
solve that?
I'm not super familiar with Llama's ability to do image processing. I would have to look into that. But certainly there are systems out there that can handle visual question answering. But definitely, I would create a data set that sort of has both the questions and the answers and the images. I would want to follow a similar process where I fine tune, look at the data, maybe fine tune again, build a data set, build a training set, build a test set, sort of all the same practices would apply.
Perfect. Somebody just submitted this one, but is there a way we can force model output, like maybe using out parsers or libraries like Instructor or DSPY?
Sure. I'm gonna assume here that by force model output, you mean force like the structure of the model output. Um, Although if that's not what you mean, please throw a comment in the Q&A or in the chat so that I can better answer your question. Perfect. I
They
got a
said
yes.
yes.
So we're going to assume that I got that right. The best that I could give you would be to use the OpenAI structured outputs method. We actually just released a blog post on that yesterday. If it went live, Nate, you can keep me honest about that. Um,
Yeah, that's correct.
if it's either out or it's about to come out, one of those. But essentially, OpenAI recently released a way that you can mandate the structure of an output from their language models. And that would be a really great way to do this. We recommend using Pydantic, which is a Python library for creating these structured outputs. And then you can pass it to your model and get a return in that way. Nate just linked that blog post in the chat. So thank you for that. And the material for the webinar will be recorded and the material is already available online. And we'll send it out to you after this document, after the webinar is over.
We'll be sending an email or reaching out with all of this information, including the notebook and the recording and the written walkthrough. So you should be able to follow along pretty closely. So all right. Well, I think that brings us to about time. So anyway, just want to say thank you to Micaela for taking time to share her knowledge and expertise. Thanks to everybody who attended, and we hope that this was helpful to you as well, and hope to see you at the next one. And in the meantime, have a great day. Thanks, y'all.
Thanks, everyone.